Hi everyone, thanks for joining us inside the Lightbloom Research Lab. Today I'm going to show you the things that I have worked on this week. This week I have worked on several things. First thing was setting up the camera or improving the camera setup. Before we were using the camera setup from behind, but now we are using the overhead view. And other thing is robot simulation in Isaac Lab. I have made the robot build in the Isaac Lab, and the other thing is setting up or thinking about the virtual environments for robot training in the Isaac Lab. So yeah, so if I will talk about the camera position, the things that I have changed is the overhead view. We are tracking our robot from the overhead. Before we were tracking the robot from behind, and the problem that we were facing was when we were tracking the robot from behind, it was just showing us the marker and the robot, and when the robot comes over the position of the marker, sometimes it hides the frame of the marker. So but if we will use the overhead view, it's so much clear as compared to previous results. And now we can see the robot from overhead view, and we can easily navigate the robot towards the marker without losing the location of the marker. If I will show you the video, for example, in this video we are tracking our robot from overhead. Here we are having our robot and this is our marker. As you can see, our robot can perfectly navigate to the marker, and we can easily see the location of the marker and the robot without losing their locations. So this was the thing that I have worked on this week, changing the camera location from different angles just to overhead view. And the other thing is I have worked on making our custom robot into Isaac Lab, building the build of our robot. As we are having the Omni wheels, so it's little bit complex to make these type of wheels in the virtual environment, especially in the Isaac Lab. So we are running our Docker container as we are having our Isaac Lab setup into our server, and the server will open the ports, and then we can via those ports and using the WebRTC we can access the virtual environment of our Isaac Lab. It will take 30 seconds to run the container into our server, and then we can access our virtual environment. So yeah, as now our Docker container is running, and we can access our container virtually like this. Here, as you can see, we are having the screen of the Isaac Lab. For now it's just empty. We can create the scene, just for example the ground plane, and I can import the build of our robot. As you can see, we are having our build of our robot having the Omni wheels. Here we are having the different wheels. It's not the normal wheels, it's the Omni wheel that can move the sideways and in every direction. So we are having the same type of wheels in our virtual environment too, having the Omni wheels and everything. The making this type of build is a little bit complex. For example, we need to have the different joints, the position of the rollers and everything, and the wheels and their joints connected to the robot body. So it takes a quite good time for making this robot build, but now we are successfully having a robot build into our virtual environment. And the next step is to move this robot inside this virtual environment. It's a little bit complex because you have to make sure about the physics and other things, that how the rollers are moving. You have to set up the velocities or everything. I'm also learning about this software. So we are having the official build of our robot, but our next step is now to move this robot in the different directions, maybe using arrow keys or maybe using the commands. So now we are having the build of our robot. So the next thing, so this was the one thing, making up the build of our robot. And the next thing is setting up the virtual environments. It's a little bit complex. For example, if you are setting up the virtual environment in the software like Isaac Lab, you have to make all of the things. For example, if you are setting up the virtual environment for the kitchen, you have to make up the shelves, their physics, the particles. So it's a little bit complex, and I was researching how can I make this virtual environment using the AI type of stuff. So I found some website called World Labs where you can make the 3D worlds just by giving some prompts or 2D images or 3D images. For example, here in this case, you can see like we are having a 3D world of the kitchen, and we are having our robot in this virtual environment. So it's like by using this AI, we can generate or create the virtual environment, and then we can export or import our robot build into that virtual environment where we can navigate with our robot. So by using this AI, it's a little bit easy to create the virtual environments, but the hard part is like to import the stuff over in the Isaac Lab. For example, if I will show you like or demonstrate the thing, how can you create the virtual environment in this or via this AI. For example, here you can see like we are having a different type of virtual environments. For example, this here we are having a bedroom, here we are having a kitchen. So it's like you are having a different type of virtual environments, and you can generate your own by just giving your prompt or maybe like 2D images or 3D input. So it depends what you want. For example, in our case, for example, here if you will just click on any of these examples, you can see like the 3D world is like they are making the 3D world, and it's like quite done. So for example, you can like navigate. It's like having the floors, the walls, the sofas and the chairs. So it's like pretty amazing. So you just have to download or the different format of this world into your Isaac Lab, and then you just have to set up the physics, and then you can move around with your robots inside this environment. And if you are training your robots, you can use this virtual environment to train your robots. And for example, this is the one case. And for example, if we will talk about this kitchen environment, here you can see we are having a kitchen environment with the different things, and you can move your robot around on the floor, on the kitchen. You can train your robot like on making a coffee, how to navigate on the things, how to find the things, the spoon or everything. So yeah, it's like having different things, having different environments, and you can create your own environments with just a single prompt or with just 2D or 3D images.